Hi, welcome to the LangGraph second video, where we will see the practical demonstration of each of those scenarios. Okay, so we had a 10 minutes video introducing how important LangGraph is when it comes to building your own custom AI agents. If you haven't watched that video, please remember to watch. So here is a quick 1-minute overview of how LangGraph is going to help us. Welcome to Techie Talks AI. I'm Sri from Shogini. On this channel, we bring you hands-on demonstrations and insights into the latest tools and trends to help you get started with ease. Don't forget to subscribe and be a part of our journey into the future of technology. When we started the AI revolution, we had an API endpoint using which we could build AI-based application. And then came a RAG, Retrieval-Augmented solution, where we could also improve the context by sending custom information by way of local vector database and similarity search. Then these AI models started offering function calling. Function calling is the way by which LLM can construct the parameters for a function and respond to you back asking you to call a function. And then next thing that happened was, using function calling, we could easily attach tools. So when an LLM returns the function name and the parameters, we could call the tool and get the response back and send it back to the LLM to complete the context and response. Then the big revolution happened with the introduction of AI agents. So agents greatly simplified the addition of local RAG database tools, etc. So you could add any number of tools, and you could also have multiple agents. Next thing that happened last November was Anthropic's Model Context Protocol. So it offered a convenient way of connecting tools to agents. And the biggest problem with an agentic system is entire sequence of operation is autonomous. So it is, you have no control over which tool is called, when it will be called, etc. Because you rely on your prompt and you trust the LLM to call these tools. So there is no certainty in all situations whether the LLM will reliably call a tool or not. So now here in this scenario, LangGraph came to our rescue, where we could build agents and that will have good control over which tool to call, when to call, and also it can decide to rely on LLM. So you have complete control over a router-based workflow and an AI LLM-based workflow. So with this much in mind, let's proceed and see how we can define our own workflow. I have already cloned the demo repo from LangChain. This is module number 1. In this video, we will not look at LangSmith. Next video, we will look at LangSmith. So let's start with a simple graph. So I'm starting this. So in simple graph, we have the start defined, and then we have a node, and this node can decide whether it should call node 2 or node 3. So that is what I was saying. In LangGraph, we can decide, we can set the condition required to allow this routing. So in this first demo, there is no large language model involved. This is demonstrating how we can route the flow. Let's look at the code. So here what we are doing is, we are defining a class called state that will maintain the state of execution. And in this case, it is a simple string, okay, str. So we are defining a class containing just one called graph_state. So here what we are doing is, we are creating 3 nodes, just independent nodes, unconnected. You see this? Node 1, and we are passing the state. So there is a parameter state. Here we can get the state, like the state with the key graph_state, and we are appending a value. So if node 1 is called, we will simply print node 1 and also append IAM to the state. A similar thing in node 2, we are adding happy, and node 3, we are adding sad to the graph state. Okay, so node 1, node 2, node 3 methods. Okay, and here we have another function. This returns a literal. It can be node 2 or node 3. Okay, and what does it do? It just get the graph state, but we are not using the graph state in this function. But if you want, we can use it. But it just creates a random number, and if it is below 0.5, we say we go to node 2, and if it is otherwise, he'll go to node 3. So there is a simple condition using which you can route the flow of execution. So that is what is being shown here. Let's execute this. Okay, so that is executed. Let's see what is happening here. So here, builder object is created, and we are passing the state to the object. Okay, and then we are adding nodes to the builder object. So these are the names of the node, and these are the functions that we have defined above. That is clear. So we have defined builder and added the 3 nodes. But the thing is, if you don't attach edges to the node, we will see how it looks. I have added a start. A start is essential for it to successfully compile. So this is where we are compiling. So we are adding the start, and this is the start. Then we are doing the compile, and then we are creating an image like this. So program execution will start here, go to node 1, and then it ends. So now we will add these edges. So builder add a conditional edge. We will add a conditional edge to node 1. So now what happens is node 1 can go to node 2 or node 3. These ends, even if we don't define, they by default will be attached, but it is a good practice to define the edge. So the question is, how does node 1 know if should go to node 2 or node 3? There are small dotted lines. So that is because when we define the function, we are specifying the literal, and LangGraph will know from these parameters that it is going to get string node 2 or node 3. Accordingly, it will detect that the connection can go to node 2 or node 3. Clear? So now what happens when we execute? It will start from here, it will go to node 1, and the random number, if it is below 0.5, it will go to node 2 and say I am happy. Otherwise, it will say I am sad. So let's execute. So this is the message, hi, this is Lance. Okay. So here it says, see, hi, this is Lance, I am happy. Let's execute it again. See, I am sad. See this? So here it executed node 1 and then node 3. Let's try again. See, node 1, node 3, node 1, node 2. So this way we can control the flow of execution. In this case, we are using a random number, but it can be based on temperature, based on some stock value. You can precisely route the flow of execution easily, just adding 1 or 2 lines. So this will make your agentic system very, very powerful. Okay, so that is the first basic demo without using any LLM. So next demo we will use LLM. Okay, so that is going to be agentic. So in this demo we have LLM. The second demo is an agentic system where we will attach a tool to the LLM. Okay, so we will attach a tool which is a multiply tool. Okay, and we will see the code now. So here, this is the tool. Here the doc string is important. So this tool will multiply A and B. There are 2 parameters. Here we are calling GPT-4o model. We are instantiating the LLM, chat OpenAI library from LangChain itself. And then we are attaching tools. We are binding the multiply tool to that LLM object. Okay. So this is an agentic system with a tool. Okay. So tool has been attached. Now let's execute this. Okay. Tool calling LLM. We have the tools and let's see what happens. Define tool calling LLM state, message state, and LLM tools invoke state message. So this is a node which is a tool calling LLM. And here LLM tools invoke and we pass the message. Then we are building the graph. First thing is to create the builder object. Then we are attaching the nodes. Okay, so tool calling LLM is one node. Another is tool node multiply. So this is the multiply tool. And here we have the tool calling LLM node. So these are the two nodes. Okay, so this is the node here. And we have the node this. Okay, so now we are defining the edges. Start is going to the tool calling LLM. Then we are adding a conditional edge. See here, add edge and add a conditional edge. Conditional edge is a tool calling LLM and tool condition. The LLM can decide to go this way or this way. So if you ask why is the sky blue, it will know that there is no multiplication involved, so it will take this route. If you ask please multiply 3 by 4, then it will take this route. Okay, so this is like our typical agent, but we can visually see the flow. Okay, so here, hello, what is 2 multiplied by 2? Let's see. Okay, so here we have the answer 4. Tool message, so it took the tool route. Here if you see, there is a tool call multiply. So let's now copy this and create another section here. Insert a cell below, and here let's see, why is sky blue, and let's execute and see what happens. Okay, sky appears blue, blah blah blah. So now here we have confirmed, and if you look at the flow, human message, AI message, there is no tool call now. LLM could decide easily that there is no need to call a tool. Okay, so that is a quick demo of attaching tools to it. So this is an agent with 3 tools. So here we have one tool, that is multiply. Then we have an add tool, and we have a divide tool. Okay, and then we are creating a list containing these 3 tools. And then like before, we are creating the LLM object and then binding it with the list of tools. Okay, so then we are creating a system message and an assistant node. Here is where we are building the graph. Like before, we are creating the builder object, then adding a node, assistant node. So this is the assistant node. Then we are adding a tools node. We are passing the tool node and the list of tools. So actually, this is not needed. You give your comments on it, because we are attaching these tools directly to the LLM object. LangGraph could have avoided this or avoided the binding of tools with the LLM. Okay, then comes the start. Add conditional edges to the assistant node. The condition is tools condition. So here it is able to retry till it meets the requirement. Here LangGraph has got a module called tools_condition. That is what we are using here. Let's compile, and what we are going to demonstrate is we are going to call these tools multiple times, and to prove that there is no memory, it doesn't retain the chat or interaction history. So let's execute. Here we are saying add 3 and 4. Okay, 3 and 4 is 7. Now we are saying multiply that by 2. So it seems that there is no number provided to multiply by 2. So it has no history. So how do we add history? It is very easy. Just define the memory saver object. So import memory saver and define memory, and React graph memory builder compile. We say checkpoint equal to memory. That is it. Just one line. So now let's say add 3 and 2 and multiply that by 2. See here, add 3 and 4, and then the answer is 7, and and multiply that by 2, we have the answer 14. Okay, so this is a short demo of how easily we can begin using LangGraph to provide a controlled flow of execution in your agentic systems. So thank you for your time. The next video is very interesting, where we will see how the same can be observed visually using LangSmith. So that also will be a short video like this. Thank you for your time. Please give your valuable comments and suggestions, and see you in the next video. Bye-bye.